All right, so this is Chapter 7, Sequences. And so there are two types of infinite sequences.
You're frozen.
I am frozen. Awesome. All right, two types of infinite sequences. All right, hopefully you remember what an infinite sequence is. It goes on forever, right? So infinite sequence instead of, what's the other kind? If it's not infinite, it is finite, which is, right, get rid of the in, and you have finite. All right, so you got infinite and you got finite. We're dealing with infinite sequences, two types. An infinite sequence is convergent. Convergent. Isn't there like some kind of movie with a similar name? Divergent. All right. Wait, that's the second kind. That's our second kind. Divergent. All right, we'll get there. All right, so an infinite sequence is convergent if as n, the series, as you keep going along the sequence, as n increases. So remember, n is what term? First term, n is 1. Second term, n is 2. Third term, n is 3, right? Again, try to refresh your memory. I'll show you that in a minute. As you keep increasing n, the sequence approaches a real number. As you increase n, you approach a real number. Okay, what are real numbers? Simply remember, it starts off with the natural numbers, whole numbers, then the integers, then all rationals, all fractions and decimals, then all irrational, all non-fractions collectively make up the real numbers, right? So as long as you approach one of those, then it is a convergent series. All right, let's take a look at examples, see if I help you to make sense of it. The first number is when n equals 1. So n sub 1 means n is 1. First term is 6.8. When the second term is 6.4, the third term is 6.2, the fourth is 6.1, the fifth is 6.5, the sixth is 6.25, the seventh is 6.125, the eighth is 6.0625. What are we approaching? So let me let you think for a second. What real number, because this is a convergent series, what real number are we approaching? Are we on 3? 1, 2, 3? 6. We're approaching 6. We keep getting closer and closer to 6. We started out at 6.8. Now we're down to 6.0625. And we're just going to keep getting closer and closer and closer and closer to 6. This is a convergent series. We are approaching a real number. It is a convergent series. All right. B, the real number that the sequence approaches is called the limit. Called the limit. Limits are the basis of calculus. And honestly, calculus is the math that makes the world go. All the things we learn really are to lay a foundation to where we can actually get the calculus and make practical application of all the math. And in that practical application involves taking things to the limit, which often involves then, so when is this the closest to 6, or when does it hit 6? It hits 6 in which is what? How do we say eventually? At, not beyond Buzz, but at infinity, right? At infinity. And calculus is based on taking things to infinity to be able to figure out their values. Really just before infinity, but to infinity. And that's the major concept of calculus. So what they've started doing in their math, we used to never teach this to Algebra 1 students, but now everything's pushing down, and they want algebra students these days to begin to at least try to get a little sense of the concept of a limit, which again is taking things to infinity. And that's the idea, and that's the concept. All right, the notation is LIM. All right, that's easy. Stands for limit. LIM. I can figure that one out. And the arrow there is approaches, and then we need, oh, that should be green, and that should look better. We need an infinity symbol. The limit as n approaches infinity is 6, right, for our example? So there's your notation. The limit as n approaches infinity is 6. Okay. All right, so here's an example. So we got to approach infinity. And so we're going to do some of the, now instead of listing all of the values, right? Instead of listing all the values, we're given the formula. And is this, what type of formula is this? It is the explicit or the recursive? It is the explicit, right? We can find any value from it. So we've got the explicit formula. Q of 1 says put 1 in for the n. Right? And so we end up with 4 over 4, and that value is 1. Do we have any clue yet what the limit is? I don't. You might not have any clue after we finish either. All right, but right now we have no clue what the limit is. We don't have enough data. Let's do Q sub 10. See, I'm getting bigger. I'm heading toward infinity. So I chose 10 as the next data point. You don't have to go in order. So in this one, we end up with 31 over 40. And let's go decimal. So if you were to take your calculator out and divide your 31 by your 40, and that's what you would do now. So go ahead and punch that out. 31 divided by 40. Somebody shout it out when you got it. 0.775. All right. I still don't have enough info to determine my limit, but I see I'm already getting smaller than 1, right? See if that continues to hold true. So remember, infinity is a long way off, so I did my next one at 100. So now we're subbing in 100, right? And we're finding the 100th term, right? That's what we're finding right now, the 100th term. And so that's a what? 301 over 400. And punch that in and get 0.750. Say it loud for me. Okay, 0.7525. Okay. I'm continuing to get smaller, aren't I? Am I sure yet where that limit is? I'm not quite sure. But I see where I'm heading. Let's do another. Let's do a grand. Subbing in 1,000. So this is what? 3,001 divided by 4,000. And somebody raise your hand when you get this one. I can't, it's hard to hear. Nick?
75025.
75025. what are you speculating right now? What are we approaching? Infinity? Well, what real number are we approaching? What's the limit? No, where we started at 1, now we went down to 0.775, then we went to 0.7525, now we're down to 0.75025. See, we're heading to infinity, and what real number are we heading toward? We started at 1, now we're at 0.75025. What are you guessing? 0? All right, let's do another one then. Let's do 1,000,000. And just for time's sake, did you figure out that that's 1,000,000? I'm sorry, that's 3,000,001. 3,000,001 over 4,000,000. You guys see the pattern on this one? And again, you could run the formula, but it's 3,000,001 divided by 4,000,000. Again, I need one person to raise their hand and tell me, Adam, what do you got?
0.75000025.
0.0000025? Okay. Anybody concur with that number? Okay. Did that clarify your picture for you? Really? If you still don't know, do a bigger number. All right. If you guys don't know, we better do 10 million. 10 million would be 30,000,001 divided by 40 million. 30,000,001 divided by 40 million. And again, when somebody gets that, raise your hand. Raquel, nice and loud for me. Whoa, slow down. All right, I gotta get all these zeros. So start 0.75, then say your zero slowly. 1, 2, 3, 4, 5, 2, 5. Okay. Can you now see what we are approaching? Don't say it out loud. I'll give you a chance in a minute. Therefore, the limit is, say it.
0.75.
It is 0.75. The limit is 0.75. And that is a real number. 0.75 is a real number, right? So at 1, I had no idea really. 0.775, all right, I'm heading lower. 0.7525, okay, I'm lower yet. Oh, I got the 0.75 again. And this part's lower, but maybe I'm going to go lower than 0.75. And here, I got the 0.75 again. And then this part, after the 5, kept getting lower. I'd have stopped there, but that's okay. You needed one more thing to help convince you. You could put in a gigantic number. You could have done 1 billion. It would have been 3,000,001 divided by 4 billion. And again, you'd be 0.75. Oh, I don't know how many zeros on that one. And you say, oh, this bottom part just keeps getting smaller, but the 0.75 stays. What's my limit? 0.75. At infinity, you would hit 0.75 at infinity. All right? A convergent series. Get rid of my shade so I can move up. Okay, so here's another example. This one, the series is listed out. So we started at 9, we went to 3, we went to 1, we went to 0.3, 0.1, 0.03, 0.01, 0.003, 0.001. Anybody want to raise your hand? Give me a guess on the limit. Adam?
0.0013.
Good guess. I wouldn't go there. Andrew? We're already past 0.1. We're way lower than 0.1. All right. Anybody else want to take a guess? Where are we heading? Nick?
0.
We're heading to 0 on that one. That limit is 0. Now that one, they give you no other capability of doing any more values. But we're just getting lower and lower and lower, and you got to assume we're going to 0 on that one. That is an assumption. Now E, we got a formula again. So let's always do 1 to figure out where we start. Can you sub in your head? 3 minus 2 gives you a 1 on the top, and 1 minus 3 is a negative 2. So this thing right now is a negative a half. Somebody tell me what value to use next. Somebody raise your hand. Everybody should be thinking. Josh, what do you want to use next? Yeah, don't piddle, don't do 2 and 3. We got to figure out all the way to infinity. You'll be there forever. Let's go z of 10. So again, this is a 3 minus 2 times 10 over 10 minus 3. So negative 17 is the top, and the bottom is 7. We better turn this to a decimal. Somebody divide negative 17 by 7 and raise your hand and tell me. Looking for people that haven't contributed. Come on, folks, contribute. Madison, nice and loud for me. Negative 2.4286, etc. Okay. All right, good. We went from negative 0.5 to negative 2.4. We're getting smaller, aren't we? If those aren't exactly the digits, I don't care. It's a good enough question.
If you were writing it down, would you round somewhere?
Yeah, I don't round. Don't even worry about it. Just dot, dot, dot. Because, again, it's just trying to help you figure it out. It's not a final answer or anything, so just dot, dot, dot it. Don't take the time to figure out the rounding and everything. Adam, question?
Oh, no.
Okay. So, what do you want to go to next? Let's go big. Want to go 100? Let's go 100. Let's go 1,000. Let's go 1,000. It's not. So again, this is 3 minus 2,000 over 1,000 minus 3 is 997. So this is negative 1,997 divided by 997. When somebody has it. Kaylin?
Negative 2.00300.
Okay, hold on. Negative 2.00300 and dot, dot, dot. Okay. Do we have enough already? Maybe. If you want to be sure, let's go. What do you want to go next? Do you want to do 1,000,000? Let's do 1,000,000. Why not? 1,000,000's not hard. All right, so again, look at the top. It's a negative 2,000,000 minus 3. Right? So that's a negative 2,000,000. So a negative 1,999,997. Right? That's 3 less than negative 2,000,000, right? And what is the bottom? The bottom is 1,000,000 minus 3. So that's 999,997. So negative 1,999,997 divided by 999,997. Somebody tell me what they got when they get it. Come on, somebody else. Come on. Come on. Ileana.
Negative 2.00000.
3 at the end. All right. Do we have enough? You have enough. The limit is? Awesome. You guys are great. Negative 2. Got the idea there? Okay. So you're just figuring out where it's heading. Where are we heading? Where are we going? It's always nice to know where you're heading. I'm heading to heaven. I hope you are. It's nice to know where you're heading. All right. An infinite sequence. An infinite sequence is convergent if as n increases it approaches positive infinity or negative infinity. It can go either way, positive infinity or negative infinity. Oh, that bothers me. That should be divergent. My bad. Let me erase the whole thing. Okay, instead of heading to a real number, we're heading to infinity. Now we are, did I do the other one in red? Yeah, so this one is divergent. Sorry about that. So convergent, you head to a real number. Divergent, you head to infinity, either positive infinity or negative infinity. A doesn't give us a ton of data, but we're progressively getting larger, and it keeps getting larger. And this one is heading toward positive infinity. It is divergent. The second example, we don't know. So let's write some data. Stick in a 1. Somebody shout out what you get when you stick in a 1. -2. Let's stick in a 10. What do you get? -29. Let's stick in a million. What do you get? -2,999,999. Where are we heading? To negative infinity. See, the numbers just keep getting bigger and, well, in this case, smaller and smaller. It's not like, you know, the numbers are staying, but the back is changing, the whole thing's changing. That's divergent. Oh, excuse me. Sorry about that. Wow, I bet that's fun to listen to on the internet. All right, let's look at C. All right, I got a couple minutes left. I got to be a little careful here. Let's do K of 1. List these this way because I got to refresh your memory on what to do here. -2, and that's to the negative n. I got to put my glasses on here. Okay. So to the -1. -2 to the -1. Remember negative exponents, right? So this is -1 over 2, right? -1/2. X to the -1 equals 1 over x, right? Boy, the rules. X to the -a equals 1 over x to the a. You can't forget your rules, folks. That's why they're on every test. All right, case of, let's go with 10. So that's a -2 to the -10th. So this is a -1 over 2 to the 10th. Two to the 10th is 2 times itself 10 times. It's getting to be a big number already on the bottom. What happens when you take 1 and divide it by a big number? All right, we better do some decimals here. This is -0.5. This is going to be negative. Guys, I know you're not good at your calculator yet on these, so let me just do it. This is -0.000976. 0.000976 ... Okay, let me do one more. -1 over 2 to the 100th. Okay, it is -7.88 times 10 to the -31st. There are 30 zeros in front of that number. 30 zeros. Are we heading toward positive infinity, yes or no? Are we heading toward negative infinity, yes or no? No. This is neither convergent. Actually, we're heading, in this one, we are actually heading toward what? We're heading towards 0. This one was convergent. I did. Awesome. All right, and one thought here. Note, divergent sequences do not have limits. Only a convergent sequence has a limit, because infinity's not it. All right, and I think you guys have it written on the bottom what to do. Yes? All right. Hey, one thing about sequences, not a ton of homework, which is good. It should take you hopefully a little bit less than 3 hours.